take a note point here.
Yes, sir.
Well, first, very important note point. There is a given spring, okay, which has a natural length L naught. Suppose natural length L naught, and which has a spring constant K naught.
Yeah.
K or K naught, okay, you can take.
Yes, sir.
If the same given spring, not any other spring, if the given spring is cut into, suppose different parts, three parts for suppose. Three parts means two places it got cut. Same spring of length L1, L2, L3. Okay,
Yes, sir.
that means what happened. So there, the same spring is cut into L1, L2, L3. Okay, this is of spring constant K1, K2, K3. Question first thing is, if the same spring is cut, will the spring constant remain same? No, it will not remain same. The spring constant will change. The spring constant will
Change.
Change.
change. How much, what will be the relation is, the spring constant is inversely proportional to the length of the spring. If I can specify to you, K naught L naught is equal to K1 L1 for the given spring, not any other spring. Understood? You don't relate two springs, two different springs.
Yes, sir.
If K1 is there, K2 will be there. So L1, L2, not like that. K naught L naught is equal to, from the same spring, original spring. K1 L1, that should be equal to K2 L2, that is equal to K3 L3. This is
Yes,
an
sir.
important note. The point is, for a spring, the value of spring constant changes with the length of the spring. For a spring, I'll write here. For a spring, the value of spring constant will change with the length of the spring. And product of KL, that is force constant, length of the spring is always of the given spring. Is always a constant quantity. Okay.
Yes, sir.
That is one point. Suppose, for an example, there is 1 meter original length spring, okay, natural length spring. Then that spring constant is 100 Newton per meter. If the spring is cut into, the same given spring is cut into two parts, okay, there will be two springs, right?
Yes, sir.
Yes, sir.
What is the spring constant of these two springs? If someone asks you, what is our value? K naught L naught should be equal to K1 L1, that is equal to K2 L2. Here the potential will become as 100 into 1 is equal to K1 is K1 into 500 centimeters is how much? Sorry, 500
5, sir.
50 centimeters. That is 0.5 meters.
5.
That is equal to how much? Here K2 into 0.5. Here that implies K1 is equal to K2 is equal to 200 Newton per meter. You got it?
Yes, sir.
Yes, sir.
Mm. That is one important point you need to know. Then another very important conclusion, another note point. You can, I'll dictate, you can write down. If a system is made up of cutting of spring and string, cutting of spring and string in a given system. If a system is made up of few springs and strings, if a system is made up of few springs and strings, few springs and strings, and if we cut a string, if we cut a string, then the forces available in the springs in the given system, forces available in the springs in the given system will not change instantaneously, but the forces of strings, changes instantaneously. Changes instantaneously.
Yes, sir.
Okay. I'll shall I explain this point, note point with the question?
Yes, sir.
Yes, sir.
This is given in one of the 2 or 3 times in previous year questions. In BitSat, definitely they might ask you, and NEET also it is asked 2017.
Yes, sir.
Similar question, not the same question. Important concept. Two blocks A and B of same mass M is attached with a light spring, are suspended by a string as shown in the figure. Find the accelerations of block A and block B just after the string is cut. After the string is
Cut.
what did I tell you? If a string is cut, what happens in the system?
It will not change instantaneously.
Yes, sir.
No. Which will not change instantaneously? Spring force will not change instantaneously.
Yes, sir.
Whereas string force changes
Instantaneously.
instantaneously means you understand this word?
Yes, sir.
Just
Yes,
after
sir.
the string is cut means at that instant, what are the accelerations? Not after some time. At that instant means instantaneously what will be the accelerations of that A and B just after cutting. Are you getting?
Yes, sir.
After
Yes, sir.
cutting the string force will change immediately. String force will change immediately, whereas spring force will not change. Will not change.
Immediately.
Immediately.
I'll use this concept and solve. So in the beginning, first let me, in the first condition, are they at rest or not? In the figure.
Yes, sir.
If they are at rest, net force should be what on to both the blocks?
0.
0. Varun, are you getting this?
Yes, sir.
If I draw the free body diagram on first block M, what will be the forces? Tell me, Varun. Cut it and pull it. Tension upwards,
Tension upwards, mg downwards,
mg downwards, or is there any other force
spring force.
in which direction? Varun, you tell me the direction.
Downward.
Downwards, because it will expand here, so it will try to compress. So here
Yes.
spring force will be downwards, Fs. Here also spring force will be. Let me ask Varun. Varun, you tell me what is the free body diagram of the second block, B block. This is A block and this is B block.
B block, upward Fs.
Okay, that's awesome. Next downwards is
Yeah. M1.
Mg.
Yes, sir.
Initially, everything is at rest or not.
Yes, sir.
Yes, sir.
At force should become 0. That is
Zero.
T is equal to mg plus Fs or not.
Yes, sir.
Yes, sir.
Here Fs is equal to mg or not. B block equation.
Sir.
If I
Yes, sir.
substitute this equation in this one, T is equal to how much?
2 mg.
mg.
Fs is equal to mg. You got it?
Yes, sir.
This is initial condition. Initially, the situation is like this. Okay.
Yes, sir.
Now, I'll solve this question carefully. See, this is M block. When I cut this string, what did I do? If I cut this string, this tension immediately becomes
0.
0 because there will not be any pulling force. For tension to happen, you need to tie on both ends.
Yes, sir.
Like
Yes, sir.
there's a light string there. If you tie it to some ceiling only, it will stay there. Tension will increase. If you cut it there, immediately it will fall down or not. It will not have any tension. Okay. Ideal string, it
Yes,
will not have any tension. If it is having mass, some tension will be there. Varun, are you getting me?
Yes, sir.
This tension force will become 0, but this spring force will not.
Become 0.
The spring force before what is the spring force in the previous case?
mg.
Now also the spring force will be
mg.
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 Now if I draw the free body diagram for this M, upward tension will become 0 or not?
Yes, sir.
So
Yes,
what
sir.
will be the forces? Mg and after cutting. Okay. Mg and
Yes, sir.
spring.
Fs.
And what is the forces on this block? Second block. Mg and
mg. Fs upwards.
Fs upwards. Are you getting, Varun? String force immediately
Yes, sir.
0 here, but spring force will not become 0. Spring force. Okay. So now, if I solve the accelerations of the block, mg net force is equal to mass into acceleration.
Yes, sir.
Mg
Yes, sir.
plus Fs is equal to mass into acceleration. So what will Fs is what? Mg. So 2mg
mg.
equal to mass into acceleration of this first A block. Sorry, A block. So ma is equal to how much? Acceleration of A block is equal to 2mg by the 2g will be the acceleration of that at least top block. Okay,
Yes, sir.
you got it.
Yes, sir.
On the second block, the force will be Fs will be upwards, mg will be downwards.
Downward.
Fs is how much?
Fs is
Mg minus mg is equal to how much? Mass into acceleration. So mg minus mg is nothing but how much?
0.
0.
So now the acceleration will become
0.
0. So acceleration of the bottom block will be 0. Just after cutting, acceleration of the top block will be 2g. Just after cutting, acceleration of bottom block will be.
0.
Zero.
Don't remember these answers. Questions might be different. But the important point is, note point is, after cutting the string in the string system, the string forces will change immediately, whereas spring forces will not change immediately.
Yes, sir.
Yes, sir.
I hope I have explained these two note points, important note points.
Yes, sir.
Yes, sir.
There's another thing, but which we will learn in the simple harmonic motion, but still I'll teach you here another thing. If strings are connected in series, okay,
Yes, sir. I know this one.
connected in series,
Parallel connections.
if strings are connected in series, the force will remain same throughout the spring. Force will remain.
Same throughout the spring.
That spring force is not remain same throughout the spring, so it will oscillate, isn't it?
Yes, sir.
So
Sir.
series connection of stable series connection of springs, spring force will remain same throughout the.
Yes, sir.
Suppose this is M, so that spring force, that entire force will be spring force, that is equal to mg. Okay,
Hmm.
but
Yes, sir.
these springs will have different expansions to make the force equal in all the three springs. Okay,
Yes, sir.
three different springs, K1, K2, K3. So what will happen? So here force will remain same. Equilibrium spring constant. I'm trying to find out what?
Series connection.
Series connection equivalent spring constant. No,
K.
question will ask you, we will ask questions like, what is the equivalent spring constant for these three springs which are in series? What is the equivalent spring constant for the three springs which are in series? So series means
Yes, sir.
I will replace this three springs with one spring which is K equivalent.
Yes, sir.
I'll connect the same system with block M. Okay.
Yes, sir.
What will happen? K equivalent into X will be the force or not?
Yes, sir.
Yes, sir.
That is equal to, entire force should be equal. Sorry, that X will be equal to X1 plus X2 plus X3 or not? Equivalent X.
Yes, sir.
Equivalent X is how much? That force by force remains same throughout the spring. That is F by
Hmm.
K equivalent or not X.
Yes, sir.
That is
Yes, sir.
equal to F by K1 plus F by K2
Yes.
plus
K2
F by
plus
K3.
K3.
So that is F cancelled. So 1 by K equivalent is equal to 1 by K1 plus 1 by K2 plus 1 by
K3.
so on. If this, there are n number of springs, series equivalent spring constant, this is the formula. For parallel displacement will be same. Got it?
Yes,
Hmm.
sir.
For both the springs, displacement will be same, but not the
Yes.
force will be same. Force will
Hmm.
be the same, displacement will be same, both the blocks for parallel connection. That means force is equal to F1 plus F2, net force is equal to F1 plus F2. So F is K equivalent into X. If I replace both of them with one spring, K equivalent to X is equal to K1 X plus K2 X. X will be the same for both the springs. X cancel. The resultant will be K equivalent is equal to K1 plus K2 plus K3, so on. So this is for parallel combination.
Yes, sir.
Yes, sir.
This is for series combination. And very another important point. Uh, Here you might do a mistake here. One case, one important case. I'll just explain you. Is it series connection or parallel connection? You tell me.
This 1 second, sir. Parallel, sir.
This is parallel connection. Varun.
Yes, sir.
Yes, sir.
Why? Because if I tilt this block in the positive direction, if I displace this block in the positive x direction, you see the spring force. This spring also is expanded by x. This spring is expanded by x, compressed by x. The displacement is same or not?
Yes, sir.
Yes, sir.
Force will be in different direction. What this force will do? This force want to be same direction. The force will want to bring back to its normal position. This spring also wants to bring back to the normal position. You see both the springs are acting in the same direction with same displacement or not?
Yes, sir.
We might think it is a series combination, but it is not a series combination. It is a parallel combination. Okay.
Yes, sir.
So I will try to say. So, did you understand this concept? This concept you will use mostly in simple harmonic motions, whatever.
Yes,
Yes,
sir.
sir.
And in depth, some other questions can be solved in simple harmonic motion topic. Okay. Then I sent you these questions in PDF. Did you get Ujjwala?
Yes, sir. I got.
Uh, on spring force questions, I sent you. You can try to solve those questions. You can try solving those questions.
Yes, sir.
Yes, sir.
This question, you can try now. By tomorrow, you need to solve all these spring questions and come.
Okay,
Yes,
sir.
sir.
Whatever the questions, those are there on the spring force.
Yes, sir.
You see here, these two springs are in series or not?
Yes, sir. I'm doing
Yes, sir.
What did I tell you? The entire
one.
force,
Yes, sir.
this is what happens. Force will be same.
Remain.
Displacement might be
Yes,
different.
they remain same.
So force remains same means what will be the force? Here I'll just try to draw the free body diagram. Now there is a spring force. It is like similar to this one. Example I'm telling. There's a spring and there is a string connected here for suppose. Okay. So now I'll just try to hook. I'll try to take this hook and all. So here on the block, 20 kg, isn't it right?
Yes, sir.
Yes,
20 g will be downwards. Tension will be upwards.
Hmm.
The tension will be how much? 20 g.
Is it
That is
20?
200 newtons or not?
Yes, sir.
yes,
Now the spring is there. Like this or not? Tension is connected or not?
Hmm.
At this place, on the spring force should be equal to the tension force or not to be in balance
Yes, sir.
at this point.
yes, sir.
That means the spring force will become tension force.
And compose.
That means Fs will become
200.
Newton.
Nothing but the tension in that string is equal to the spring force in the spring balance. Okay.
Yes, sir.
Some students will do one mistake. Now, if reading of the spring balance, this is 1, I'm assuming. This is 2. If the reading of the spring balance is 200 newtons, what will be the reading of this balance?
100 newtons.
200 newtons. The spring force will remain same throughout. Did I tell you or not?
Yes, sir.
In series, spring force will remain same. In parallel, spring displacement will remain same.
Yes, sir. Yes, sir.
Yes, sir.
You remember that in the previous?
Yes, sir.
So now this is 200 means that is also
200.
200.
200.
So sometimes the reading will be like this. In your book you can see reading will be in did I teach you in normal reaction? If the reading is apparent weight, if the reading is 200 newtons, the answer will be 200 by G. Did you remember this?
Yes, sir.
Yes, sir.
Reading
Yes, sir.
is
I remember.
such a way, reading is calibrated in such a way that it is divided by G. Here what we got is 20 G or not?
Yes, sir.
Divided
Yes,
by G is how much?
20.
20.
20.
20 is the reading on the spring. You don't get confused, okay?
Yes. Yes, sir.
It is calibrated like this.
Yes, sir.
Your weighing
Yes, sir.
machine. In hospital, you will see a weighing machine where you will find it to be 10, 20, 30, 40, 50, isn't it?
Yes,
Yes,
sir.
sir.
But actually it weighs your weight, not mass.
Yes, sir.
What
Understood.
they will
Yes,
do
sir.
is, if you are weighing 4, example I'm telling, if you are weighing 480 newtons, that will be divided by, that is 9.8, which will give you 50 kg. Got it?
Yes, sir.
That means your reading is 50 kg, means that is 50 into 9.8 newtons. Got it?
Yes, sir.
It is calibrated like this.
Yes, sir.
Next, you carefully solve all the examples I sent you and also all the questions that I sent you. Are you getting clarity of spring force or not?
Yes,
Yes,
sir.
sir.
It's easy. Questions are easy. Why much? This question? Is there anyone? What is the answer here? Tell me. The tension will be equal to spring force. Okay, tell me.
0, sir. Answer is.
Answer is 0, is it?
Yes, sir.
They
How
are in equilibrium. Same weights, no, sir.
is it?
Yes, sir. Because same weights, they will have. No, sir. Both ways same means, that means what? There will be no tension. It will be equal to 0.
The question asked is it tension? Reading of the spring balance. Okay. You see. If you see on this 1 kg block, there will be
Minus
tension
1.
upwards, 1G downwards. That means tension is equal to 1G.
10.
If you take G to be 10 newtons, isn't it?
Yes, sir.
Similar way, right side string also will have 10 newtons or not?
Yes, sir.
That means
Answer 10
at
Newton.
this end spring force is how much? 10 newtons. And at this end
10
spring force
Newtons.
10 newtons.
10 Newton. 10.
expanded, so spring force will be trying to compress it. So that should be equal on both ends. That is equal to 10 newtons, bus.
Yes, sir.
You got it, Ujjwala?
Yes, sir.
The spring force will be equal to the tension. Here it is not 0.
My brain is not working, sir.
हो गया? 1.5 hour after your brain is not working. Now you got it?
Yes, sir.
Varun?
Yes, sir. Yes, sir.
So the tension will be equal to that spring force.
Yes, sir.
You can try solving whatever the question I sent you. Any doubts are there, you can ask me in the next class.
Yes, sir.
Varun,